So, hello everybody. I guess some of us are already here, and maybe we wait a little bit more, several minutes, so that few more people can join. I guess this time it is like a good opportunity for people to look into the chat and see that you understand the environment if you haven't had an opportunity to look into Zoom. And I guess there are many people, or at least in potential, we may be 40 people, because that's the number of people who joined. And so please look and see that you can mute, that you can turn off the audio, so that everybody can hear better. And I guess we'll just start very soon. Any questions for now, I guess? So probably, I guess, maybe it is a good time to begin, and maybe 2 or 3 dozens other people may join through the meeting. And so what is it about? Can everybody hear me okay? Could like some of you write something on the chat so that we can see? Yeah, great, wonderful. So this is Scicloj, a group of people that started creating some things together in the last few months. And what we are trying to do is build a Clojure data science community. And I think this meeting was originally an idea of Alan Marazzi, that some of you know, and he is not here today, but I'll just use the way he phrased it. He said, we're here because we wish to make Clojure one of the 3 main platforms for doing data science. And actually, why not? We'll have more meetings of this kind rather frequently, and there are already 2 other meetings in the oven. And so maybe today we'll not talk too much about what is Scicloj and what we are willing to do and how we work, but in short, very briefly, we're trying to build a community, and we're trying to allow people to create together, to be aware of what each and every one of us is trying to do, and try to be in some coordination in the libraries that we write. And one of the exciting things that I've seen in the last few months is what Chris is going to talk about today. Just before we begin, let us try to use the chat as much as we can, and then if anyone wishes to ask something or talk, then you can write it there, and then we'll ask you to talk, because we might be too many people to talk all the same time. And so Chris will talk for maybe half an hour, or if there are more questions, then more. And then we'll have some discussions of some topics that we wish to discuss. And what could be nice is that if anybody is beginning to talk, then that somebody could say some things about themselves, like my name is that, and I'm from there, and I'm doing, and I'm interested in that. And you can take like a minute to talk about yourself. It would be nice. Does it make sense? Yeah, any question? Wonderful, wonderful. So let us begin. Oh, sorry. Yeah. Oh, hi, Thomas.
Hi.
Yeah. One more thing, all this process of creating meetings and other kinds of communication that we are working on in the last few weeks is a joint work of a group of people. And Chris Nuernberger and Tomasz Sulej and Alan Marazzi and Joyner, that you may know by this name, are all part of it. And everybody are welcome to become part of what we're building and to influence the process of building a community. And so let us talk about it if you're interested. And also many thanks to Chris Zhang, who was part of the process in the early parts and now is doing something else. So I guess it is a good time to begin with the talk of Chris. Chris, would you like to begin?
First, can you hear me? Can everybody hear me?
Yeah.
Sure. I would like to begin. I have a set of slides that I'm going to attempt to share, but when I'm sharing my slides, I won't be able to see the screen or the chat. So if Daniel, if you could stay unmuted and let me know if something's not working, I'd appreciate it.
Sure.
And so, how are we doing?
Yeah, wonderful.
I've put together just a short set of slides that I'd like to talk about in order to explain where I'm coming from and where I think things are going and just why I built the things that I built. So let's talk about that. Let's start a conversation on machine learning and numerics in Clojure. And I think there have been existing things in this space. I do not think that those things represent the extent of what's possible with machine learning and numerics. And so I think there's a lot of space for conversation yet. So real quick, I'm not going to talk that much about TechAscent, but we're 3 people. We have a broad spectrum of contracts, lots of industry experience doing lots of different things. And all 3 of us are senior engineers and senior developers and somewhat senior C-level executives. So we've managed people, we've managed projects. I've seen languages come and go. I've seen some really good ideas get forgotten in the history of time. And so I think that, you know, that's some of where I'm coming from is this sort of background where I like to think of the history of computer science when I build things. And I like to think of very long time frames and long views of what has happened and what was interesting and that kind of thing. I hope you guys can read this. The font's not too small. This is only the slide that's got a lot of text, but the foundation behind Techml, or rather the target of Techml, not the foundation, has 2 branches. One branch is for Clojurists, and it's really for Clojurists who don't know much about machine learning and who, for instance, really haven't worked in MATLAB once, maybe ever, never used pandas. And what you do is, you know, you program a bit of Clojure day in and day out, and you have access to Datomic or an SQL system or an Excel spreadsheet. So you have access to a rectangle of numbers, and a lot of times in Clojure, that rectangle is going to be a sequence of maps. And then what is the shortest path that you can do some machine learning on it? Get some graphs, look at what's going on, do simple regression and classification, but do it in such a way that you're going to get a result that's competitive with somebody spending a similar amount of time in Python or R for some subset of problems. And so that's one target. The other target is people who program in pandas and Python and R. I tried to think of what would be interfaces that would look similar to what they were used to, or at least wouldn't feel like they were jumping into Alice in Wonderland and in something that was totally very, very different than anything that they were familiar with. And so it's basically, you know, for some subset of problems, the Techml system would work for you. And if you want to try it out, here's a pathway that doesn't force you to relearn the foundations of computer science and what you're used to. So there's two targets, and those are the two audiences that I designed this system for. So I can't see the chat while I'm doing this. So if somebody could notify me if there's an interesting question popping up, or maybe we'll address questions at the end. Probably the best thing is we'll address questions at the end of the talk. So you are kind of the things I was shooting for when I built the ML system. And I don't actually think I hit all of them, and I will talk about that in a second. But basically, you know, the first thing is low drama. And that's actually probably the most important one. If you look at Kaggle competitions in the last 2 years done with Python, there's really not a lot of code there. Almost never do you see a whole lot of code in any of them. So there have to be really direct paths to do those types of things. And that's going down the easy route and not the simple route. But in order to make it worthwhile for people to invest their time in the platform, it's got to be similar amount of work to do the familiar things, in my opinion. And so that low drama is simple, not fancy ways to do things that are going to feel familiar to people who've been doing them before. We have a data pipeline so that you can do a lot of data processing. And this is where one time, I think, I'm not sure, but I think one time Rich said that Clojure should be really good for this because it's so good at manipulating data. And this is totally true from my perspective, but column store mathematic data is a different animal than a sequence of maps. And so the more you get to the actual base numerics of data, I think the more awkward any base language gets, and you start moving into what you really need a numerics language to do it in a way that is gonna feel really good. Then model search, and I wanna talk about this. This is really important for a lot of reasons. And the main reason is that machine learning is really hard, and there are a lot of details. Every model has 8 or 9 details to it that will make it work great or not. Pretty much all of them, from XGBoost to ridge regression to neural net, where you take the number of details you need to manage and square it, essentially, or quadruple it, or I don't know what. But neural nets are far more effective, far more detail and fiddly kind of things to mess with. But in any case, there's almost nobody in the world who can look at a data set and do a little bit of initial processing on it and then tell you which model is going to do best. And I think that if there's someone who tells you they can do that, I don't believe them at all. Not a human brain is not a machine to do that type of processing. So we just want a way to run a range of models across a problem and see which ones did best. And sometimes, a lot of times, you're done. You don't need to even worry about why that model did the best. You got the accuracy you needed to move on, and you can stop. And sometimes you can't stop, and you need to understand, like, why did a model do better or not? But that's a second step. The first shotgun step is, I have a rectangle of data. I want to predict one of the columns of the data, which model does best. And once you figure out which model does best, you can look at the hyperparameters used to train it, blah, blah, blah. But basically a searching mechanism across this massive space of different things that might possibly solve your problem, I think for me is really important, because there's no other way I've figured out to do information hiding, where you don't have to be an expert in each model and still get decent results. Performance, reasonable performance, you know, reasonable. It's not gonna be, I don't know that we have the time to build something that'll perform in every situation as well as pandas or Python or something else. But a lot of times we're using the same underlying libraries. So the actual training probably will perform just about as well. But in any case, reasonable performance out of the box. And you may or may not know, I've researched the best in the world compilers for numerics. I've put a lot of time into this, and I have options to use one of them. And so reasonable performance with options for world-class performance if you want to put the time in. On the other hand, I think nobody will probably want to put the time in or will need to unless you have a very specific problem. And these are out of order, but that's okay. I'm going to flip the order in my head and I will reorder them. So play well with C. And that's key for me. And maybe that's because I have such a strong C background, but that's important for me. And playing well with the JVM means we have really easy ways to move data from primitive arrays and back into Clojure. And there are easy ways to manipulate primitive arrays, and not only that, but NIO buffers, which are an abstraction of primitive arrays that are significantly more powerful because NIO buffers can work on native data structures as well, or native contiguous arrays as well as primitive arrays. So all the Java libraries that are built on primitive arrays have essentially made a choice to weaken themselves considerably because they could have done the exact same algorithms on NIO buffers, and then they'd also work on native data structures as well. Play well with Clojure. Obviously, that's important. Clojure's ability to handle just basic data processing and transformations. If your problem looks like a transformation from a data structure to a data structure, Clojure's dominant. And it's amazing, and it's beautiful, and it's probably a lot of the reason why most of us are here. But there's got to be good ways to go from the ways that make Clojure really efficient and effective to these other ways of representing the problems that Clojure doesn't play as well with in its native form. Playing well with Python and R, I've talked about that some, but it's kind of clear who, you know, the big dogs in the room are. It's not the JVM, and there's nothing on the JVM that's anywhere near Scikit, in my opinion. And I'm not an expert in R, but it seems to me that playing really well with these two very important ecosystems is really a key part of the game. And before potentially rebuilding things in those ecosystems, playing well with the things that exist and making a nice library that just wraps Python with a shell call is probably not a bad idea. And yeah, you take an efficiency hit in a lot of different ways in terms of programming time, but if you're, for instance, training images, so if you're doing image rec, your actual efficiency hit is irrelevant because all the time is spent in the neural net in the training process. It's not spent in Clojure, even if you're inferring on images. So there's a set of problems for which the actual machine performance is irrelevant. We've pretty much maxed out machine performance for it. So if you access that pathway through Python or R via shelling out or via some other mechanism, you're really not taking that much of a hit, and you're taking no actual realistic hit in a lot of ways. And the last one is open. And so I want to be really clear about what this means to me. And this means that we can talk about what the Techml system, and we can criticize it, and we can choose to not use it, and we can choose to use it. All these things need to be totally okay. So I'm not trying to build something that I'm going to stand on a platform and say, look, if you're not using what I built, you're just being irresponsible, or you're being ignorant, or I'm not trying to build anything like that. And I have felt that energy before building things in Clojure. I just have to be honest. So I want to distance myself and say, mainly the most effective use of Techml in a lot of cases is going to be generating conversations and generating ideas that potentially don't use it or go different directions than it does. And that's fine with me. And that's a key concept behind what I build. That's one reason why I don't do certain things with this tech. So openness in that sense, in terms of furthering conversations in constructive ways, is really important to me and the foundation behind TechAscent and lots of different things. So moving on, I've done a bit of machine learning in Clojure. I think And so I've just got some thoughts on the ecosystem, and I think there's actually nothing missing. I can build nice wrappers around things, which shorten the pathway to doing X, Y, or Z. And we can all talk about what makes certain things work or not work or feel awkward or whatever. But for any branch of machine learning I can think of. And so I just don't see a big hole anywhere. Walking through this list, you know, we have literally 20 matrix libraries. Some of them support sparse, some of them don't. Some of them extend to matrices that don't fit in memory. Some of them don't. But whatever, we got a lot of those, a lot of those. We have a few probabilistic libraries. There's another one in here I didn't mention because I couldn't find it in time, but Dragon has one that is GPU accelerated. And so for some subset of problems, that's probably a good choice. Dataset processing, you know, table saw is not a new project. I just heard of it 3 months ago, but it's not a new project. It's mature. It's been around. I wrapped it with ML dataset, and there's Spork, which I hope you guys can see also. And Spork is a column-wise data store that's built on persistent data structures. So in that sense, it's more Clojure oriented. It's easier to use from Clojure and integrates deeper with Clojure than the stuff that I built. On the other hand, we found that TableSaw is very efficient for big data sets. It stores data much more efficiently. And that's potentially something that's solvable in Spork using different sorts of persistent vector type things, but who knows? Classic ML algorithms, oh man, there's a lot. So both me and Tomas, if I said your name right, I apologize if I didn't, wrapped Smile, and Smile has more than what I did, and Fast Math does considerably more of a percentage of Smile than what I did, but Smile has more than that. Shogun, which I think is the way to go moving forward, just based off what I've heard of it and a little tiny bit of research, and XGBoost. And there's 10 others than this. I'm not kidding. So Intel has one. There's a lot of tree gradient boosted trees and this kind of thing. So in terms of the classic ML algorithms, I just don't believe you need to write anymore right now. I think that there's plenty of ways to get at different things in ML. And the NN-based approaches, I can't say enough about MXNet. A lot of the recent stuff has been really impressive, and I really would strongly advise anybody going that direction to try MXNet first and really try it. On the other hand, I think the classic ML algorithms apply to exponentially more problems than the neural net based approaches, and I have to say that. So, but that being said, I'm stopping. MXNet is brilliant. Karen's work in that is really, really good. And then there's another one, TensorFlow Scala. TensorFlow is a different design than MXNet. So TensorFlow is more like you have an abstract syntax tree of math, and I do the things on it. And that's also interesting to me for a lot of reasons, but you have two NN-based approaches you have access to, and both of them are big industrial platforms that man, are real powerful. Then NLP, which is text processing. I don't know much about NLP. I haven't spent the time to really go down it, but there are things that exist. And so I think that's also totally doable. And quite frankly, there's been Java NLP libraries since, I don't know, forever, 2005 or something like that. It's just not modern NLP, but it's still there. So I think that we don't need to be implementing a lot of these algorithms this way. We need to build on top of these things, unless potentially you really know one of those algorithms and you can think of an edge that the other libraries don't have. And then if everything I said sounds like nonsense to you, my strong advice is just use XGBoost. Just use XGBoost. Maybe via Techml, maybe just raw. I don't really care. But if everything sounds like nonsense, just use XGBoost. So what are the requirements to, if we're going to ask somebody to say, hey, invest time in our machine learning platform, like we think it's really good, we think it's worth it for you to invest a lot of time in, to bet your career on, what are the requirements that we have to support in order to validate that question, or in order to feel good about asking somebody to do this, you know, because I feel like machine learning, it's an investment. And if you invest all your time in a platform that never gets used, you get to invest some of that time just relearning another platform that does get used. Or if you invest time in it, or worse, if you invest time in a platform that doesn't scale or doesn't actually solve the problem, then that potentially you walk away from that entire investment. So the first thing I think is important to me is proving that the platform does actually work. And right now, I think it's actually easy in machine learning as compared to, for instance, computer graphics. Because you have a set of these fairly difficult machine learning problems. You have them solved in an open way with a bunch of tools, and we can pick off the problems just one by one and make sure we're getting good results for those problems. And that to me is really, really important. I don't believe that people will spend a lot of time learning how to do machine learning in Clojure unless there's some subset of problems that we can prove we get world-class results for. And that's just my opinion, but that is really important for me. And I think as far as that goes, there are simple machine learning problems in Kaggle that don't have Clojure analogs proved out for them. And we have Alan set up a Trello board. I think Alan did it. I'm not sure who did. But somebody set up a Trello board where we've listed kind of like, here's a bunch for NLP, here's a bunch for this type of thing, here's a bunch for that type of thing. And having, regardless of the toolkit you choose to use, having those demonstrated in clear ways, I think goes a really long way. Because as I said, I feel like, and this has been true for a while, this isn't just in the last month, I feel like we have the tools in Clojure to do all this, but because of the complexity of the domain of machine learning, without having clear and simple examples of using those tools to get world-class results, you're still asking a lot from someone to try to do a lot of their machine learning in Clojure. And plus, every one of these things that I do, I learn a lot myself, and I learn about deficiencies in the things that I'm working with. Changing gears a little bit. I just want to talk about my experience with Clojure a little bit, and talk about kind of what I hear a lot from people and trying to sell consultant services in Clojure, and trying to talk to people about why I love Clojure. And this, I feel like, you know, popularity contests are not something I respect in any great amount. I've never won one and never probably will. I don't think Clojure will either. Except salary, that came out recently. That's a powerful one. If you're gonna win one, then probably salary is a good one to win. But for a lot of reasons, I feel like Clojure's not gonna win the popularity contest, and that's fine. It's not actually a problem that's meaningful. And so how relevant is this to what I'm talking about? And so I feel like this informs the direction I take when I'm building something. And so Clojure's the underdog, and everybody loves to root for the underdog, so that's an advantage. But because it's an underdog, most of the software that's really great in this world is going to be built in other languages. And so making it really easy and building effective low-code integrations with powerful software is the fastest way to scale the language, in my opinion. And that's absolutely an opinion, but I think there's just so much really good software written in other languages, especially C and C++ and now Rust, that Clojure, it's such a natural companion to Clojure. You know, for any problem you come up with, any realistic system you come up with in computer science at all, I can tell you the best way to solve that problem is going to be a mixture of a garbage collected language and a non-garbage collected language. It's just obvious to me. And that includes, a computer game. That includes most of the big server systems or microservices systems that you're talking about. Any complex thing you're talking about is going to be a mix of garbage collected and native. And unfortunately, I feel like mixing those two is still awkward. And that's funny to me because I feel like Microsoft made a really strong push to mix them years ago and it failed. But that's just my opinion. It's just natural to move between garbage collected and non-garbage collected worlds for any given problem of a given complexity. So that being said, I feel strongly that C family integration is part of what makes everything tick. So I've researched this a lot. One important thing is, how do I take a native resource and bind it to the garbage collector in a meaningful way, or bind it to my program stack frames? And after doing the research, I write a little library. And that's about where the research stops. So we have a set of libraries at TechAscent that are built around C family integration. If you want to integrate with a C thing, I think I've built things that'll make it easier. Even if you choose not to use one or two of them, some of them are probably going to help. And as far as that goes, some of this is also asking nicely for our brethren programming C++ and Rust to produce ABIs, binary interfaces that are in a C subset. So that means structs, plain old data types that don't have meaningful constructors or destructors, and that are just data, where memcopy fundamentally means memcopy equals semantics work. And they use functions, they use function pointers, and they use contiguous arrays of plain old data types. That's it. Anything more than that, and you're drastically reducing the number of languages that you can work with. And so some of this is trying to work with the experts in C++ who are producing these amazing things and say, I know that it's like cutting off your arm, but a C ABI would help me use this. And the truth is, once there's a C ABI, you can use it from CPython. You can use it from Rust. You can use it from Julia. You can probably use it from R, although I don't know. And you can definitely use it from Java using JNA with no further work on their part. That is substantially less work than them building their own JNI wrappers, than them building their own Python using Boost Python, than them building who knows what. I mean, it's just obvious. Put a nice C interface on your shit and then stop. Walk away. So the JVM's another area. And because of really good design decisions really early on, it's not that hard. I'm not going to talk about it much. One of the base libraries that we've built everything on is meant to work with contiguous buffers of primitive data types. And that's because it's so core to integrating with the JVM in so many different ways and with C systems in so many different ways. And that's where it comes back to the NIO buffer point I made earlier. But it's more than that. You'll see more about this later. I'm gonna start writing about it. But basically, most of this is already there. The library I wrote, the data type library, probably helps in 5% of the problem, but that 5% is kind of important for performance reasons. That being said, all the time, almost every Java library I use, I end up using reflection to bore a pathway through. They almost always make something private that is really important for somebody else to get to, especially for performance reasons. And it's just the nature of the game. And quite honestly, that's always been my experience with languages that have strong language-based protections in them. So that's true of C++, where I've seen people, for instance, for the people who program C++ in this room, one time at NVIDIA, I saw somebody who pound-defined private to public before they included a header so they could get to all the private things in the thing. And so for every single bit of protection I've ever seen, I've seen it broken. And that's just the truth of the matter. And so reflection's a piece of that game, and getting good with using reflection to bore a pathway is part of that game. Real quick, consulting with Clojure is an interesting game, and it could be, we're still learning how to do it. We could be doing it wrong, but it's the first few years of it have been a lot of learning. So the only cost so far to Tech Ascent of Clojure's niche status has been that I talk about it a lot. So we go to D3 meetings, and I go to coffee clubs in the morning, and I go to these things, and I like to give presentations on things. And so if I can find a group of people who are interested in a thing, I might build it in Clojure and then talk about it. And that way it's a nice way to say, hey, this is one of the strengths of Clojure here, or this is not, potentially. A lot of people who want to talk to us are worried about what happens when the engagement ends. So they are concerned about their ability to hire or train Clojure engineers. And that's just is what it is. It's always a big system we're working with. We always have to interplay with lots of different things. And where that's concerned, embedding Clojure script in larger JavaScript applications is unwieldy. So if they have a large, for instance, Vue.js app, and we'd like to write some portion of that app in Clojure script, that gets pretty hairy pretty fast. So I think that's just a thing. That being said, once the contract's signed, people are really happy with the outcomes. Clojure is such high leverage that the three of us can do things that teams of people have problems with. And that is an outcome of the language being homo-iconic. That is an outcome of us having 40 years of experience doing these things. And that is an outcome of our very diverse backgrounds. The three of us have extremely different backgrounds. And so if you combine all those things together, then man, you have a lot of potential for speed. So the last thing I want to say, and some of you have probably heard this before, and I saw that you joined the call, and I want to credit, I have to credit Ben Camphouse with this, the kernel of this. I'm not sure where it came from. It came out of discussions with him and various other things, but basically the Clojure community is very, very small. And there's two varies there, not one. We'll get a lot farther building bridges than we will building islands. So that's my talk. I hope you guys liked it.
Yeah, thanks, Chris. That was beautiful and eye-opening. Can you hear me okay?
I can.
Yeah, wonderful. So I guess that it would be a good time for questions and discussion. And can you see the chat now? Many people are saying thanks. And I think it was beautiful for everybody, I guess. So would it be a good time for you to open it for discussion, for questions?
Absolutely. If anybody has anything they want to say, please, let's talk about it now.
Yeah, wonderful. And I guess because we are not like 40 people as I thought we would be, then you can just open your audio and speak. And maybe if you feel comfortable, open your video to everybody so that we can see each other and get to know a little bit of who we are. Would that be okay? If anybody wants to ask anything? And also, as I mentioned, when you speak for the first time, please talk about yourself. So maybe I'll ask something, Chris, and I'll talk about myself. My name is Daniel, and I have been doing data science in Clojure for the past 6 years into startups. Nowadays, in a startup called Localize, and nowadays I'm interested in our interop as the thing that I'm trying to build, and I hope to be able to release something soon. And also, that is something that is happening here at my workplace. Some really interesting connections between R and Clojure, and I hope that something can come out of it. And what I wish to ask you, Chris, is could you tell maybe a little bit more about the ETL part of your project? I know it is still maybe alpha, but it is so interesting. I think.
Yeah. So thank you. That actually is a big piece. So that you were there at the conception of that idea. We were talking about it, and I basically, Alan said, you know what? A lot of people are building these complex training pathways, and then they go to productize them, and it's tough. And if you have a big data set, I think it's really easy to see why it's tough, because you're going to do things like replace the missing values with the mean of some part of your data set. And then during production, you have to remember that mean. So if you get the same missing value, you can use the same mean. And so there's these bindings of data that you generate during training beyond the models that you trained, and they need to be represented in the actual production process. So that combined with a complex regression demonstration on Kaggle that I found. Basically, I cut and pasted the pandas and translated it into Clojure data structures. And then I implemented a system that would run those data structures and produce the same result the pandas did.
Would you like to maybe show a code example?
Yeah, let's, sure. Give me a second to find it and to get my other stuff off full screen. So that was mainly the biggest thing, and it was helped a lot by the fact that I built a lot of the systems behind TechAscent, you know, the numerics libraries and all these other things. These systems were built in order to integrate well with other systems more than anything else. Like I have systems where you can add a number, add a column to another column. And that was really easy to integrate because it was built to run on top of Java arrays, and then it had to run on native arrays, and then it had to run on the GPU. And so I have kind of this general purpose middle ground fleshed out of doing some numerics, but on unknown data structures. Let's move. Okay, so here we go. I'm going to share my screen again real quick, and let's, ooh, yeah, that's frustrating. So I'm going to show some subsections from it that I think are interesting. When I said, this is actually one of the things, I got a lot of feedback right when I made this, and I agree with all of it, but I like to let feedback sit for a while and let people try to use it in various different ways before I change anything. But you can see that here, you know, the pipeline, this is a good example. Replace missing with none. If you didn't have an entry in the alleyway column and you needed to replace it, you'd have to remember this in production. And in fact, all of these, this is a good example of the things that are just a pain in the, are painful to deal with, because you have to carry all these little bits of data around, and you have to re-engineer your whole training pipeline, or I mean like 90% of it again, when you go to production, and hopefully you didn't make a mistake, but probably you will, and you'll get answers that are kind of right, but not really wrong because you used the wrong mean somewhere or something like that, or they're only wrong for some small percentage or whatever. But it's a really error-prone process to carry this sort of data set engineering and re-engineer it. As you can see, like sometimes we do pretty in-depth replacing of values for various reasons, and you get to re-engineer all that in a different, slightly different context. So if it's a fixed value of replacing, you know, that's not very hard. But when it does come down to, for instance, well, yeah, replacing things with means or some specific thing, you'd really like a lot of data. The end result of your training process isn't just your models. It should also be a pipeline. And the truth of the matter is really the pipeline should be a graph. And running the pipeline is a translation from one graph to another graph. And the second graph has your models and all your intermediate data in it. That was too aggressive. I didn't want to do that as my first try at this. I wanted to get one clear Kaggle example working, and I did. And what was really nice, let's see if I can find the correlation table that I produced matches to, I think, the third decimal place with the correlation table that Pandas produced. And there's a lot of processing before we ever get to this correlation table. So that felt really good when that happened. That was the result of a lot of work that didn't happen by chance. So anyway, this notebook example is literally line for line, almost exactly the same as the Kaggle example. And I don't always want to hold to that sort of exact matching because there's things that are more efficient to do in one system if you structure them slightly different. But for this example, I felt like it was important. And I think that was the impetus behind a lot of the pipeline. I've gotten a lot of feedback on it. One of the most important points I made earlier was that, the whole system needs to be simple and without drama. And I feel like the pipeline misses the simple aspect because it's so data oriented. You can't really use the pipeline without quoting things and without doing a lot of other stuff. And that is your second step. Your first step is going to be a bunch of data set engineering and getting a model that trains well. And once you get a model that trains well, your second step is going to be productizing it. So I think I made the productizing portion relatively too important, and the actual data manipulation portion, while it's very efficient in this format, it's still awkward to use from the REPL in an exploratory fashion. So that is something I'm going to address, and version 2 will have a set of fixes around all this kind of stuff. So I think that, is there anything else on the pipeline that you'd like to hear about?
Anybody? I guess anybody, you could just speak if you wish, because we are not too many people. Any questions on that? Yeah. Yeah, we can hear you.
Oh, thanks, Chris. This is Chris Sang.
Oh,
no, hey.
Yeah, it's a really great talk. I think I agree with you on a lot of what has been said. We are a small community, and actually that is a huge problem. So what I'm finding here in China is that there are just so many developers, and there are so many teams of developers doing crazy shit. And to get a leg up on them is very difficult. So Clojure is definitely helping. But again, I totally agree on the outreach. Like it's very difficult to get both newbies and experts being interested in something like this. The only way that I got people interested was to show them the salary, which just came out like 2 weeks ago. And I thought that was really interesting. So the Stack Overflow results actually helped a lot in terms of, adding credibility to Clojure. So for instance, before it'll be like, yeah, we built this really cool thing, and people will be like, what language are you using? And it will be, oh, Clojure. What is this language? And now there's a, I just show them the salary, and people go, oh, okay. And there's no argument around that anymore. So that's been pretty cool. But again, I know that experienced Clojure developers experienced Clojure developers are very rare. And people that want to get experience in this language is also very rare. So I think I really enjoyed the talk, and you've said a lot of things that really resonated with me. So
thank you.
Thank you.
Yeah, wonderful. Sorry.
Oh, yeah, I was just going to say, I think the Kegels, having a set of Kegels for people to learn off of and get some use of the tools is a great idea. And actually, if people are interested, it might be a good setting to have a meeting like this to go through a Kegel to attract newer people. So just an idea.
Yeah, wonderful. So anybody else want to ask about the code of Techml or other aspects of the process that Chris did?
Hi, this is Rich Hickey.
Oh, hi.
Yeah, I thought it was great. The one thing you talked about, which I think is super critical, is the C linkage. So, I mean, you made a point at the end, which was, you know, let's build bridges and leverage other things that other people are making, and that's sort of the point of Clojure in the first place. In the original design, being able to take advantage of Java libraries was a fundamental idea, right? You know, a new language is going to be small. You need a base of libraries. It seems clear, though, that the libraries that need to support R and Python do so via C. And so what Clojure, in my opinion, is missing most is the C linkage, the ability to sort of automagically tap into libraries written for Python via C linkage. And so the stuff you showed around that was particularly interesting. And my question is, how much of the C interface stuff is actually that C subset as opposed to C++ and more challenging? It's how common is the C binary model? Because I think that is the first problem we have here, that if we could transparently tap into sort of anything that's been written for Python, we're in a great place. We're in the same place we are relative to Java. And so that's my question. You know, how common, the stuff you've built that does that bridging, how useful is it? How often can we apply it? Because what I see happening too often, I think, is we build things in Clojure on top of Java or Scala who've already sort of encapsulated the good bits of interacting with C, and we don't get the power that they have, for instance, to do model definition. We have to use their model definition stuff a step removed. So is that C subset common, you know, 50% of the time, 80%, 20%?
It really depends on how good the team is that built the library. So let's talk about really good teams put the C interface on it themselves. So TVM, for instance, which is the tensor VM that I'm really impressed with, one of the languages that has world-class numerics performance, undeniably. It is built by DMLC, and really it's headed by this man named Tianqi Chen. He puts a C interface on everything that he does before he puts anything else on it. So MXNet, for instance, has a C interface at the base. And I can use JNA to use MXNet without using any of the Scala or Karen's work. I wouldn't do that, but I could. And it's useful for me at times to do that if I want to use TVM specifically with MXNet. So really good teams are doing that at times, but it's very rare, in my opinion, that, you know, somebody who wrote a lot of C++, telling them they have to define an interface with C really is very painful to them, because now it's like, oh man, that's so much extra code, and all my template parameters I now have to code up explicitly, and da-da-da-da-da. So they're not fans of that. Rust, I think people are more fans of that. And then there is an option that is not based on a C interface, and that's Java CPP. And Java CPP uses a parser to parse a header, to parse the actual C++ headers, and can export raw JNI bindings. And auto-generates the JNI bindings, and you compile them and you build your own library. This is so far less ideal in lots of ways than I would like. Number one, the they used their own C++ parser, and they didn't. I'm hearing a little bit of something from the mic, but that's okay. They used their own C++ parser. They should have used Clang. So Clang would correctly parse all known C++, but instead they wrote a half-done one in Java. That being said, when I have wanted to bind to a C++ library that Java CPP supported poorly, I wrote a C++ header-only wrapper that would get compiled in the shared library. So it's doable. It's just awkward. And Java CPP is not as well designed as JNA. So you have two levels. You can get to C++. It's just not as good as when there's C. The percentage of what we're running into, more modern things, I think, are done with binding, because everybody wants R and Python to work now. They don't want to have to write their own thing. So I think at least in machine learning, potentially the world's coming around.
So to follow up, you said you wouldn't use MXNet through the C versus through the Scala and Clojure on Scala. Why would that be?
Well, number one, I don't want to disrespect members of the community who've built a decent wrapper or on top of the existing thing. So that includes Karen, but it also includes the Scala people. There are reasons why I don't want to have, a jar dependent on Scala version 10.2.5. The month of day of December 14th. And that dependency is hard because Scala compiles so much stuff at compile time. And so there's an argument towards just using JNA and JNAing into MXNet and going. For instance, as I said, TVM integration, but there's also there is some level of work that Scala and the Clojure bindings have done that I don't want to replicate. Unless I have a really good reason to, and then I would do it without apology.
Great. Anyone else willing to take the discussion?
Yeah, hi, Martin here.
Hi.
I work on Next Journal, and yeah, like if we're talking about integrating like with R, like I think certainly growl VM is also going to be interesting. Have you worked in that direction as well?
I've never taken a look at that.
Yeah, so like fast R is like an alternative implementation of R for growl, and yeah, they do have Python as well, and Ruby even, and yeah, there you get zero interop between all those languages, and like you could even like theoretically, or yeah, they do have an LLVM compiler as well, can interpret LLVM bitcode as well.
That's really interesting. What is the advantage of going that direction versus using the JVM as the basis of that VM?
It is then running also on the JVM. I guess Karen has looked at that quite a bit as well, right?
The last time I looked at it, the Python stuff was kind of like POC. Like they wanted to get it working, and they knew that getting all the C stuff and all the fiddly bits working was the tough part, and they were just beginning to work on that. So I have no idea exactly where it is. It was just kind of like in the hello world stage the last time I looked.
Yeah, but yeah, Oracle I think has like 50 people working on it. They're making quite good progress, I think.
Yeah, maybe I'll just comment. So actually there are at least two versions of R ported to the JVM. One is so-called fast R, which runs on growl VM, and the other is Rengine on the usual JVM. And both of them are indeed R in the sense of the R language, but both of them are lacking many libraries, which is, in a sense, one main reason to use R, the huge collection of libraries for statistics and data visualization. And so they are not there yet as a usable, just complete solution for R, but it is something we should follow and be aware of, the way I see it. And what it is interesting for is having on the JVM a true version of the language R that is being able to parse R code and interact with R code, but not just yet with the huge collection of libraries. Anyone else? Yeah, so maybe, I guess, we still have time, and before we move to the more broader discussion of what we are about and the community questions. So, Chris, what do you think? Maybe you could show a little bit of your source code so that people could like get to know a little bit of what you created and the various tech libraries. Is it a good idea?
Hey, can I ask a quick question before we
yeah.
switch gears? So my name's Joe. I'm a full-time Python/Scala person at a massive Fortune 100 company, and I dream of working in Clojure and try to find clever ways to convince my boss it's the go-to route, so I could get those giant salaries like you guys. So just from my perspective, I think a lot of the reason Clojure is so interesting to folks like me is because of its core principles around its core data structures, it's leaning towards immutability, all that good stuff. When I see the data science that we do at my company, it is notoriously undisciplined. It is a mess. So I think just one of the things that comes to mind for me is I understand growing the community is definitely important, but I guess I'm worried a bit about growing the community at the expense of compromising kind of those core priorities of Clojure that I think ultimately made it so successful. So yeah, I guess that's more than a comment than a question, but I don't know if anyone wants to reflect on that or if that makes any sense.
It makes some sense, and I definitely feel like the libraries I built are not as axiomatic as a lot of the original language design. Of course, I didn't spend nearly the time on it, and among other things, I just need more input and more good ideas to make it that way. I think that for me, you know, some of this goes back to Simple Made Easy, where the axiomatic stuff is orthogonal and infinitely composable, but my target audience is, at least for the Techml system, is not people who are going to compose it in new, crazy ways. It's, as I said, fairly newish machine learners on the Clojure side who just have some data and they want to do some stuff with. And it is, you know, people from Python and R who want to do some machine learning in Clojure, or you learn some Clojure, but don't want to totally learn a new definition of how they do things. So I think given time and a lot of thought, we can move portions of this stuff into more axiomatic principled designs, but that takes time and thought that can't happen quickly. At least I am not of the level where I can do that really fast. So yeah, does that help?
No, that makes sense. Yeah, it sounds like, you know, we need to kind of toe the line, and you're being mindful of that. So that sounds right to me. So I think some of the root of it for me at my work anyway, we have statisticians first, kind of programmers second, and then me, and I'm losing all my hair trying to clean up their mess. So I think at the core of it for them is really just the literate programming notebook development. Whereas if I could get them into REPL and start to think about not mutating everything over and over and over again, that might be a killer feature. And I think I read that in someone's blog, and who knows, it might even be on this call, but the REPL might be the thing that beats out the notebooks for me someday. if there's a way to put that graph or that scatter plot in the REPL and then kind of get our data scientists to start thinking about this is a function rather than a mishmash of all this other garbage. But yeah, that sounds good.
Well, I think there's, as far as that goes, there's another piece to that, that is you have to be able to do realistic problems and complete them in a time that is interactive. So realistic problems are big, and doing big things in a functional way is different than doing small things in a functional way. So that's where having a real numerics library and having a strong numerics background where you can have the option, and the default is immutable, but you have the option for mutable when you get in a hole because you have a lot of data. That's, that was also, in my opinion, one of the core designs behind Clojure that was really smart. Was it wasn't functional or bust. It was functional first, but pretty mutable if you want second. And that is fair, I think. And that allows you to get the performance, which at least my experience talking to people who have tried to use Clojure at times for machine learning has been when the performance is promised and then it's not there, that leaves a very strong bad taste in someone's mouth.
Yep. Sounds good. Well, thanks for the talk.
You're welcome.
I think Patrick put a question in the chat because his video isn't working.
So repeating the question really quick, what would be your sales pitch to clients about why they should go a Clojure ML route as opposed to the more common routes? Oh, thanks, Martin. It was great to hear from you, and we will definitely go further with your idea. So as far as that question goes, I don't, at this point, if I'm the one doing the machine learning, then I will do it in Clojure. But I wouldn't go to somebody out of the blue and say, hey, do you, for instance, they're getting pitched by a Python shop. I'm not going to go with them and be like, do it in Clojure. I wouldn't assume I could win that battle. And it doesn't matter how right you are at the end of the day in that situation. So, I like the language design behind Clojure a lot more than Python. I did a lot of Python. I did a whole lot of code generation in Python back in my C++ and game development days. So all the reasons that make Clojure great aren't things that you explain to a business exec, or at least they're not things that I would feel comfortable trying to pitch on a lot of times. So if you're going to do a small web app or an application where I can really know I can hit Clojure's strengths, then sure, I'll pitch that against anybody. But machine learning is not there yet. So the answer is I wouldn't right now attempt that battle. And hopefully soon I would. But before I can attempt that battle, lots of people have to have had success with Clojure and machine learning. There have to be lots of notebooks of people doing it successfully. There has to be at least a couple Python people who are like, man, I did this in Clojure and it worked great for me. And there have to be a few R people who say the same thing. And until that happens, I just feel like you're fighting such a big battle, I wouldn't attempt it.
Yeah. Now we're a little bit into the second hour of the meeting. So maybe let us try to conclude this part soon. And I thought if there isn't any other question to Chris, then I thought it could be nice to see a little bit of the code structure of what you have built so that people can get to know where to look if they wish to contribute or whatever. Is it a good idea for you to show something?
Man, showing code, I really am going to struggle with how to do this in a way that's...
So maybe another time.
The code is dense. I write dense code. I'm not sure. I'm going to publish. I have a new thing coming out. I've been working on a lot. For instance, I took an APL program and wrote it with my new system and got it to work. So My love is old school numerics, and APL is the granddaddy of them all. And for those of you who don't know, I would say John McCarthy and Ken Iverson are absolutely at the top of what mankind has ever produced in terms of computer science. And so I think that Ken Iverson doesn't get the credit he deserves because his language is very obtuse. But he wrote it in terms of describing math, and he never intended to make a language out of it. And so he just used it to teach math on whiteboards at universities or at businesses. And then he wrote a language out of it, and that became APL. And his understanding of numerics and his understanding of how to operate in a realm where machines were so limited, and yet he could do these intense mathematical transforms and he could do them efficiently, I think there's a lot to learn there for me. And so I will have blog posts about that soon that will be more code oriented. Yeah,
wonderful. So maybe let us conclude and thanks Chris again. It was really wonderful. And
you're welcome.
So now it could be time for an open discussion of where we're going to. And so what I suggest is that we ask ourselves the question, is there anything missing to have Clojure as an easy, friendly tool for data scientists? And what, in your opinion, everybody, may be missing? And the answer may be something that is a very far wish you're looking for, or maybe something that you're building. And I know that some people here in the audience are building something, so it can be an opportunity to take a few minutes and talk about something that anybody is trying to do. And does it make sense? Is there anybody who is willing to talk about their wishes or their work nowadays? Thomas.
Happy to.
Oh,
it's Henry here. Hi there.
Hello.
Got in just under the line quickly. So I'm Henry Garner. I wrote the book Clojure for Data Science. I am a jobbing data scientist. I try to use Clojure as much as possible, but equally I can't write a lot of the libraries that I need, and it's easier sometimes to reach for R. And so although I don't have any particular proficiency as an R programmer, I'm sure I write terrible R code. I write what I need in order to get the job done. And I have a sort of side project, a series of side projects really. Kegels is the main library that I'm known for. Uses transducers to do simple statistics.
I love the way that library is written, by the way. I think it's beautiful.
Oh, that's very kind of you. Thank you very much. I'd love to write more. I have a 7-month-old daughter. At the moment, I can hear her downstairs from time to time. So my output has definitely decreased recently. The key thing on my wish list, and I think Joe kind of touched on this, I've never got on with the notebook style of working. I mean, I'm sure it's just me. Obviously, they're incredibly popular, but I'm most at home in the REPL, most at home in Emacs. I love to do as much as possible there. And so the thing that I miss most is exploratory data science. You know, I know that I can use Clojure to build, you know, anything if I give it enough time. But when I'm confronted with a new data set and all I want to do is discover kind of, you know, its shape in a kind of abstract sense, I want the quickest path to getting some visualizations. And at the moment, accomplishing that in the REPL, well, I mean, I just don't do it. I go to R. Ashamed as I am to admit it, because Kljplot just makes that very, very easy for me. And so the library that I would write if I had more time right now is not addressing, I think, the substance of your talk, which I thought was fantastic. But my particular headspace is quite different at the moment, and it's in how to scratch my own itch. I don't think it would make necessarily Clojure a more popular language for data science, because you're maybe not going to reach that audience of people who don't even know why the REPL is important to them. They want to do their job in the easiest way possible. But for me, coming from the Clojure side of things, a REPL-based exploration of data, which allows easy visualization, would be big.
That totally makes sense. The way I do that, all of my demos, everything like that whole notebook, I first developed it in the REPL and used Oz for my visualizations. And the reason that I think Oz is great is because it relies on Vega and Vega Lite. And I really like the design of that language. And I really wish Vega was ported to one of the graphing libraries in Java so that I could use Vega without having to bounce to Clojure script and back. Because when you're in the REPL, obviously you're bouncing. Actually, I do a big markdown file or something like that. And then I just view the whole thing at once and just refresh it all the time. So it's clumsy. I think actually he's on the call. Tamaz has a good way. Yeah. Tamaz, could you speak a little bit about how you do these things? Because I think you have a way of doing this.
Yeah. Hi, Tomasz Sulis speaking. Maybe let me introduce a little bit myself. I'm from Poland, and I'm writing. I wrote and I'm writing some libraries for Clojure. It's. Do you hear me? Yeah. Okay.
Yeah.
Perfect. And it's a fast math. It's a library which wraps Apache Common Math and Scala and not Scala. Smile library written in Scala in Java. And currently I'm producing the charting library, which is written directly on JVM. So it's in the contrary of current approaches, which is web-based approach. You have a lot of libraries based on Vega and JavaScript. So I decided to, because of limitation mentioned partly by Henry, I needed the library which is easy to use from the REPL, and is able to save and display and generate hundreds of charts at once without needing running the web browser and saving from the screen. So I'm producing plotting library. It's a Cljplot or Cljplot. I will share a link soon. It's still in a very, very early stage. It's a work in progress. So what I'm doing now is producing. I work on Emacs, using Emacs and REPL and Cider. So I will go through the ThinkStats book. Probably you know this. This is a very, very basic book which explains basic statistics, but I use it for my test force and such examples. I use these examples to test my library and test the approach. If you click a link here, it's a markdown file produced directly from the Clojure.
Oh, yeah, you can share your screen if you wish.
Ah, okay. I can share my screen. Wait a second. Where is it?
Somewhere above the. Oh, sorry. It's at the bottom, a green button.
Sure. Yes. Okay. Thanks. Okay. Sure. Okay, so it's part of ThinkStats second edition, chapter 4. The author of this book made everything using Python, and I decided to work through this Python notebooks purely in Clojure, using TableSaw as a data frame library, my plotting library, and FastMath. So you can see here, this is an example. This chapter is about about some PDF
Probability distribution.
probability, yes, from the taken from the data, CDFs, PDFs from the data, so you can see charts which are in line inserted here as an images. It's a generated markdown file direct from the Clojure. So it looks like that. Let me show another the source code. I made 4 chapters already, and the source code looks like that. It's a markdown with as a comment, and just pure Clojure code. Nothing more. So that's the idea. So I don't need any notebook library, any Cljplot, etc. I just write in the Emacs and generate the markdown. I will show you the scripts. This is the script which generates the markdown file. It's barely speaking 23 lines long. It's using Marginalia, a parser, and just generates a markdown. Nothing special. And for me, it's easier and very easy, very easy to work with. Just pure editor, and later, before publishing, I generate markdowns, and that's all. Okay.
Yeah, that is really exciting. And if I may ask about it, then
yeah.
I guess what Henry said is not only about needing a visualization library, but also about being able to have a decent REPL session for exploring data. So could you speak a little bit about how your interactive process of working with data looks like? Because you wouldn't want to render everything all the time, right? You would like to look into little bits and pieces of it. Right?
Yeah, it's okay. It's yes, I agree. It's problematic. It's still problematic. I really wait for Chris's Techml dataset library for using it. I asked Chris already to take a look to this to my think stats examples, and to think how this direct table saw calls could be changed to the Techml dataset. Currently I use let me show you data. Currently I have some small wrapper around the table saw. It just wraps.
Could you zoom in a little bit so that everybody could?
Yeah.
Thank you.
Sorry.
Beautiful.
Maybe it's too much. So I have loading data, column accessors. It's everything. Everything, or maybe well, not everything, but part of it I saw in the Chris's library. So I hope to exchange this simple wrapper to the Techml data set. But because I started doing this before Chris published the dataset and ETL, so I decided to stay with it to push things forward. So what we have here is a selectors, creators, accessing the rows, updating columns, etc., etc. It's really simple, and here we have missing values, successor, select values, create column creators, table creators. some simple protocols about not the number values or missing values, and something which prints table, and fmap which maps data and stays with the type of table saw type, the table saw column. So let me show one more thing. Yes. So here's the example when we have kind of exploratory analysis of the data set. So I'm taking the shape, print some rows and columns, column names, etc., etc. Like in Henry's book, yes, there is a chapter when you do exploratory analysis. So you can see the size, access some values. For example, value counts is the same as Panda data frame method is frequencies. So it's an exploratory session here using this wrapper and printed to the markdown. It's as well. It's a first chapter of this Think Stats book, so it's literally the same with the same results. So that's all. So that's.
I really like this approach. I like how clean it is, and I really like going from the book and respecting, for instance, the way it looks in Python. Even if you do things in functional ways instead, so you get a thing back instead of mutating the thing in place, or vice versa. I like it. It's really nice.
Thanks. I like it too, but yeah, as Henry said, and we discussed before, data frame library, yes, it would be very, very helpful. I'm happy to that table saw exists. I'm also happy to operate with sequence of maps, but yeah, we need to think how to produce or provide common set of functions, or common set of protocols. Part of them are done in core matrix, but not for exploratory analysis, I think. Okay, that's all from my side on this.
Yeah, this is just great. Anybody wants to ask anything for Tomasz?
Yeah, I'm using. This is Chris saying. I'm using Thomas's library. Cljplot is really good. The lattice feature is really good. So it's like where you have like 3 plots and 4 plots. Like you put 12 plots all in a row at the same time, and he's got a really good language for adding plots to the bottom, to the top, to the sides. Like it's very cool. It's not easy to get used to, but I think the language is really well designed, especially in building graphs. So yeah, I really love the library, and I look forward to what he's going to come up with. It's really cool.
Thank you, Chris. As I mentioned before, it's a very, very beginning stage, so I build the basics and how the charts are produced and how they are combined. And maybe if you want, I can show some examples. Everything is on GitHub, so I'll share a link soon. Should I show or not? Anyone interested to see?
Yeah, just show the examples that, like the lattices. I think they're great. They're just they really like I don't use R, but I'm sure that there's so many features that yeah, I don't use R, so I don't know, but I think you're actually going through the R book and just generating things, but it's been really helpful for me so far.
Okay, wait, whoa, it's not like that. Okay, this way. So what I'm trying to do with charts, I try to replicate Vega and replicate Lattice R library, Gplot. And add something more. So you can see here. Do you see this? Is the screen?
Yeah.
Okay. So you can see here exact the same examples as on Vega side. So you can see every plot, every possible plot here with its histograms, bar charts, line charts, area charts, scatter plots, bubble plots. This is a chart with confidence, so some statistics like confidence sorry, forgot the word. Standard deviations, etc. Stack area charts, normalized, stream, etc., etc. Of course, binned histograms, something related to the data, some sizes related to the data, as well as lattice, which is faceted plots or trellis plots. It's yeah, start trying to replicate as well chapters, and it worked very well. So you can see the variety of things, even drawing parts. Again, 2D heat maps, and maybe some the other examples which are not in Vega or Lattice. It's a lag plot, not lag plot. It's ACF plot. It's a complex function visualization. It's a map with density. It's some vector field function, trace flow function, vector field flow. Again, heat maps. It's a lag plot. It's a logo. It's some function with a side plot. It's again density plot, stacked charts together. Again, vector field, scalar field. Oh, that's all. Currently, I'm working on cleaning the stuff, configuration, and building the ETL to DSL. Sorry, to make charts higher level, because currently, when you want to stop sharing, when you want to build a chart, you have to write a very verbose piece of code. So that's the current state. I put the link for the repo in the chat. Okay.
Yeah.
If I may, Martin Varela here. Tomas, this is like really awesome stuff you're doing, and I've been following it on the Clojurians discussion and so on, a bit lurking there. I'm not contributed, but it looks awesome. I was just wondering, you had your exploratory session there. You had kind of a nice DSL maybe for accessing the data and shaping and so on. do you have a plan? Because you mentioned that you were thinking about porting that to the Techml stack. Would it make sense to have this kind of Cljplot-like API for this type of exploratory data with several possible backends, like tables or Techml or something like that, that we could abstract a little bit on top of the kind of low-level data set functionality to have this kind of R-like experience for the exploratory data and the plotting and stuff like that?
I think question for because my exploratory session was done very straightforward. I used just Java library. What I have in mind is use Chris library from Techml stack. Is higher level. It uses different concepts behind, like tables, or like just pure sequence of maps. So this is question more to Chris, if it's how to use it as exploratory. His dataset library, how to use it as exploratory library, and what should be there to have such pleasure to work with, like in R or Pandas or whatever.
Yeah, so I think Thomas and I have talked a lot, and we're both on top of table saw. So, you know, I wrote a lot more stuff around concatenating data sets or joining data sets or doing math on the columns, doing hard math potentially on the columns. So in that sense, if you, the difference, so far what I've seen, the difference between the two is not much. So if you, for instance, I will take a look at these and look at how hard to do this exploratory stuff will be to do in the Techml system. But I don't, it's, I would say that if you chose to, for instance, just go with what Tomas wrote, and then later on you wanted to use Techml, the difference really isn't going to be that much. So there's no strong argument one way or the other at the beginning, especially for exploratory stuff, in my opinion. Yeah, that's kind of all I said. And I just, when I built the data set abstraction specifically, it was more geared towards taking a concept and training and making it production, because I felt like that was one thing that I could add to the conversation that Pandas didn't have. But the truth of the matter is, and I do think that was true, that was accurate, but the truth of the matter is most of your work is exploration. So I kind of geared it towards adding to a conversation and not gearing it towards the most practical thing I could have done. And so version 2 will be geared much more towards exploration. I've heard that loud and clear from like several people. And the people who've done exploration with the tool set that I built successfully so far have been basically building big pipeline generators. So they've been doing big grid searches across the space of pipelines they could possibly do. And that's a different form of exploration, but that's much higher level than I got a new data set and I have no idea what I'm looking on. How do I even get a feel for what's going on?
Yeah. All right, thank you guys.
Yeah. So we are like too many minutes before the official end of this part of the meeting. And maybe we can keep a little bit more with this part and ask, is there anybody else who wishes to talk about their wishes or about anything they are building or beginning to build? What do you think?
I can, this is Joe again, so I can comment on something that's worked for me. And, you know, my goal is to sneak Clojure into my company so I could be a full-time Clojure programmer and not have to switch jobs. And so data science is one aspect to it. That's very alluring. I have a lot of internal customers that are making a mess in Python and R, and I'm having kind of limited success in sneaking Clojure in and building systems that add value so they're win-win for my company and for me. Where I'm having a lot of success is actually in the streaming area. And we haven't really talked at all about Spark, which I haven't had success with, but in the Kafka space, I have had a lot of success. Even insofar as kind of calling models built by other statisticians midstream and things along those lines. So I don't think it's in the context of this discussion, but maybe it's useful for folks to kind of, I'm sure everyone's thinking that that sort of thing would certainly be possible with a lot of the tools and techniques that we're talking about. But my general workflow is I get a statistician that saves a Jupyter notebook written in Python as a PY file, and seriously, the last one they sent me was 12,000 lines of Python code. And I look through that garbage and I try to figure out how to get that into a kind of Kafka data pipeline to have a near real-time streaming scoring data flow. And
did you say 12,000?
Yes.
Not 1,200?
12,000 of the same trash over and over.
Wow. There's no abstraction there.
No, they don't think that way. But you know what? The executives don't care because they get the right answer. They think they get the right answer. And of course, there's no test, so I can't rewrite it and factor out too much of that code confidently. So yeah, I try to quarantine it and encapsulate it, and then just hopefully leave it to die on the vine until someone comes up with a better model that's cleaner. But yeah, that's what I've been up to.
Yeah, and what could be the answer for that if we have to try to reimagine?
Am I coming through okay? This has been Camphouse.
Yep.
Hey.
Yeah, sorry, my VDC assistant crap has tingled up my camera, and I've tried to kill all, and it hasn't freed it up for Zoom. So I'd have the Zoom on, the camera on otherwise. So I was going to talk about that a little bit. So one of the kind of Clojure data science success stories that's worth looking at on the streaming side is what the HCA guys are doing. They've given a couple conch talks. They have this kind of Kafka data streaming workflow. I think one of them is called like Clojure versus cancer. Or no, sorry, versus sepsis. That's the one. And there's another one. The other thing is, the notebook thing, this is something that happens a lot, and why I'm personally kind of cautious about how to reshape the work of like the notebook workflow and doing things on the Clojure side. Notebooks are a good tool for sharing, and the main thing they accomplish is that they inline visualization and programming. So it's less of the literate programming side and more so of the being able to do visualization without context shifting to looking to even to another monitor or a website or something, or a folder directory where your visualizations are getting dumped. I think that's the main time-saving thing, as I kind of commented. A sideway there. The problem with that is people get in this conditioning environment where their only means of getting, okay, I did something, I'm going to do something else like that. I don't have an abstraction where I'm forced to use or led towards using functions and parameters and doing stuff that way. And especially if you lack that sort of training because you come from some ambient numerics background that may not be computer science or software engineering, even if it is computer science driven, you tend to copy and paste cells because that's how you get one new cell from another cell. And so of course that kind of stuff piles out. But I know that that is one of the areas they were concerned with. They had a lot of different data scientists doing different stuff in various notebooks and things, and they were trying to consolidate the workflow around event streaming and data streaming models. And they're in the kind of space where the on desktop or the instance view of the numeric side of having native contiguous arrays in the right transpose order isn't really what they're worried about. They're already streaming stuff, working with the reality of network latency and when events fire off of machines out in the world. So that's what most of that stack is around. And I know they've got some open source platform there. The other thing is I am doing some client work right now. It's a fairly open client, but just, in terms of being a little conservative, I don't want to talk too much about it. But I'm curious if other people are doing much integration of Datomic anywhere in the data science stack, or how much you're integrating with Python or R teams. It seems like this is a common pain point. Yeah, I guess so. So I'll turn over to the first question. Is anybody else using Datomic anywhere in their data science workflow, or am I kind of a one-off here?
Not yet, for us. I have kind of on my to-do list to put some kind of proof of concept work together with Datomic as compared to, well, it's actually a Cosmos DB collection, which is Microsoft's slant on, I guess, Mongo and that stuff that we really don't need. And immutability would be super helpful. So I need to turn that into kind of my executive's language and then weigh the pros and cons and see if it's a good fit for our system. But not yet at our shop anyway.
Cool. Well, so one of the things that we're coming out that maybe will not be of that use to many people is one of these problems of disparate sources for data for ETL. More of the scaled sense rather than kind of the local Panda sensor into a machine learning model sense. And this is, the work here is there's lots of different scientists with medical or biology training programming in R. And this is a way of providing a tool for them to remap things in a data-driven way using one Eden file to go from various different tables and things they prepared on the R side into a Datomic schema, and then letting queries drive that, and those queries are being written in just against an R library that uses plaintext JSON to make the query. So rather than going over transit or going over an Eden Python parser or something like that, you can work from the query grammar to come up with a plaintext compatible representation that only has a few edge cases. Anyways, the reason I'm mentioning this is it's already on our plate to open source. We just don't know what the timetable is for these things. And we're not sure with the ETL library if that's going to be open sourced as a library or if we end up leaving it kind of as is and it just comes out as an example.
Ben, where do you see Apache Arrow fitting into that?
So Apache Arrow is something that, or any of these other, wrapping or similar JVM efforts, they seem like something that's right on the side that's proximal to the model or to the person doing numerical analysis. So for example, if you were doing this entirely in Clojure and you didn't have people doing things in R, it would be on the other side. So you would have queries that would come back that would get parsed automatically into your pandas like table. So then all the follow on that work that you do would be against that, which is what they're doing right now effectively is they issue these queries and they get back, the tuples in the data log query get parsed into tables on the R side or R data frames, and they do all that work against R data frames. With visualization and whatnot, sometimes if the queries are for really large objects or blobby things, there's another step to read that out. The ETL side is the interesting one because what it is doing is Clojure becomes a vehicle by which they're kind of harnessing or tangling the mess of all the data science practices of, we have in different schemas, because every time somebody comes up with an idea about how to look at data in R that basically entails a schema for the data. And rather than becoming a one-off view or something like that, or somebody's own idiosyncratic working thing, everything that gets preserved into a table of that one-off form. So if you need to sit down as a researcher to combine insights from multiple data sets, the problem is trying to make sense of in different schemas where every single data science workflow produces data of an arbitrary schema that you have to figure arbitrary in the opposite sense of what Datomic means, right? A schema that could be anything that you have to figure out immediately when you sit down with the data set. So a lot of what this work is about is getting stuff into a common representation and then making it so that the data scientist can get an immediate insight into that. But the thing that's interesting about it is as a model to possibly, infect data science systems with Clojure. To bring things a little bit back, I really liked the way the talk was framed, and thanks, Chris, you're doing really. So I also personally put some time into trying to see what I could figure out of the TVM stack, and I don't even remember all the different kind of low-level optimization things or whatever over the winter. And I realized I'd probably bitten off more than I could chew, and I was delighted to see that you guys had all independently jumped into that on the TechAscent side. So I'm super grateful to see all that TVM work pay off, and there being a way to reach directly into that rather than just the MXNet abstraction at the top, which is also super powerful and another important tool chain there. So thanks on that side. But the other thing I wanted to say is in terms of how to frame it, is I think it makes sense to frame it, the goals for Clojure data science the same way that Clojure's goals are largely framed, right? Which is Clojure should produce a clear advantage. If you work in Clojure, you want it to produce a clear advantage. You don't want to go convert every R or Python person that you know to Clojure. You want to be able to be pragmatic around working alongside them. But what you want to get out of the libraries, what you want to get out of everything else is out of the fact that you have, good metaprogramming facilities and everything, et cetera, else in Clojure, is that there's an obvious choice for somebody who knows the Clojure data science side to work there because they will have an advantage. And that means, specific things like I build something that works better, or I build something, or I iterate faster from prototype to production or to the initial prototype, or I build something that's more reliable. When it goes out there, it has less of an ops footprint. There's less time spent maintaining it, fixing it, etc. And there are certain things that Clojure already does extremely well. So like, tangling it, or sorry, I don't like that. I'm struggling for the right word here, but going out and mitigating a lot of the other kind of damage that ad hoc data science workflows can produce in terms of understanding data or coupling to data sources that you didn't know you were coupled to, or things that are hard to reproduce in production that worked in a prototype, et cetera. It's already good at addressing some of those things, and it can go in and do that without necessarily having to displace the software that's being used to produce models or to do the low-level numerics here and there. And so I think that's a reasonable strategy to take when you're trying to come up with a compelling case for Clojure for a business where it's not being used. Of course, to get data scientists writing Clojure primarily, I think is a much longer struggle, and I think it has to be kind of an iterative path towards figuring out what the other advantages you can pull in here and there. The other thing I wasn't sure is how much people were looking at the Julia community or paying attention to the things they're doing.
A ton.
Yeah, because the thing that's really cool.
So I pay real close attention to Julia. And so far, what I've seen is they have a more thorough numeric stack. So their numeric stack goes up through complex numbers, which is similar to APL, by the way, which had that long time ago. So the same kind of stuff you can do in Clojure, where your numerics can go from a byte to a double, depending on your operation and real fractions. Julia has this, but one interesting thing that they have is they have auto compilation to a thing like TVM.
Right.
You can just write straight up Julia code, and it has an auto compiler that can put it on your GPU for some subset of problems, or it can distribute it across 1,000 GPUs for some subset of problems, which is, I think, it's hard to do that with Clojure and metaprogramming. I've thought about this a lot. And some of it comes down to the language that you're using to do it. So that's also why TVM is so interesting to me, because I think it points a way forward in the long run to building extremely highly scalable systems.
So this is the thing that's interesting to me is, so you're talking about like FluxML and Zygote?
Yeah.
Yeah. So the thing that's interesting about Zygote is so if you guys aren't familiar with Zygote, it does auto differentiation as a compiler extension rather than by making you use a tensor library, like, PyTorch, TensorFlow, et cetera, whatever. The way they work is if you use their library extraction, that will provide some means in the way that the operators are overloaded for doing matrix math to track everything done, whether it's tape-based autodiff or whatnot, and use that as the foundation for auto differentiation in those frameworks. What Zygote does is it says, I'm actually going to do auto differentiation on a more primitive representation in the compiler. And that is based on the fact that Julia is built by Lisp weenies, and in the middle of it, there's Femto Lisp, and it's using S-expression expansions and concells as the primitive, as the basis for doing that auto differentiation. The reason I bring that up is because this comes out of them having found some old, Lisp paper on auto differentiation that they were able to use in their metaprogramming model. to provide all this, and elsewhere, down in the Julia stack. The thing that's interesting about that is that they're taking advantage of this data representation that their language has, and finding research that applies to it and coming up with things that make a clear, advantage. You can say, if I go to Julia and write a set of different things against FluxML, I don't have to use a completely different library. I can just use normal operators and matrix operators, et cetera, and I get that functionality for free because the language does a whole lot of heavy lifting for me. And in general, I think this is the weakness that Python and R are going to have over time, is the language does not do any heavy lifting for you. The work is always done behind an API call, and it's done explicitly in C++. And if there are lessons learned or time saved at the library level, those things are always either libraries that are reused by the people doing the C or C++ programming, or they're new iterations on the technique that enabled that.
That's interesting. I've thought about that a bit with all this, because I do so much bridging between writing code on the JVM that's literally stored in like native JVM stuff. That's confusing to say that. Stored in a Java array. And I write a bunch of code that's then using a native buffers. So it's allocated with malloc. And because Python's so primitive in a lot of ways, and the interpreter's not very powerful, they had to go to native things really early, right, which gave them a lot of performance once they got over that hump of having to go to native things. And some of what I'm talking about, like building bridges to other worlds, this isn't really a Clojure problem as much as it's the JVM problem. Is the JVM is dangerously powerful within and of itself, not having to bridge to another world. And it makes those bridges much more rare. So they're coming much later in the process. So a lot of the ML stuff we're writing now, I'm finding out how to build a bridge to C++ or C. And in Python, they had to do that literally 15 years ago to get anything working whatsoever. Whereas in Java, we got a lot of like parallel cult and things like this that work on the JVM, but they're never going to be optimizable by TVM. Or if they are, it's going to be much weaker because Hotspot has so much worse SIMD performance than native C++ does, or a lot of other things. So there's an interesting bridge there between, I can do it all in my language. Well, yeah, then you built your island, versus I can't do anything in my language and I have to just build bridges. I got no other choice.
Yeah. And, Chris and Ben, I'll just
Ben,
stop you.
Go ahead.
Yeah. Oh. Sorry. I'll just stop you for a moment, because we are at the 2-hour limit, and maybe some people need to go home. I guess, so maybe it is a good time to conclude, and then we can just continue the conversation, because it was fascinating. Does it make sense?
Sure.
Yeah. So I guess what we have had here is like one talk, and actually several other things that are worth a talk in, maybe in the upcoming meetings. And what we intend to do is meet every couple of weeks, 2 or 3 or 4. And I guess anybody here, if you wish to talk about anything, then let us talk about it, and let us just set a meeting, because we just saw that it wasn't too difficult. And what we are about in the next few weeks is doing other parts of building of a community, which means having a website which is a hub of all kinds of information, of tutorials and libraries and places where people can discuss. And what we are also have been doing is trying to build little work groups where small groups of people can have focused discussions of topics they wish to think about together. So one group is discussing ML stuff, and another group is discussing tutorials, and another group will be working on a website that we'll have for the community. And so if any of you is willing to take part in this process of building a community, then let us talk. And as I said, several of the people here, Chris and Tomasz, and Alan and Joanna, who were not here, and earlier Chris Denk, were involved in this process. And I guess if anybody has to leave now, then thank you so much for joining this meeting, and let us meet again soon. And now, I guess, let us just continue as much as you're willing to keep chatting, because it was fascinating in the last few minutes. Yeah, so sorry for stopping you for a moment. Ben, I guess I just stopped you because you were going to say something really fascinating again. Yeah.
Can I ask, Ben, what were you looking at TVM for?
So I was looking at TVM separately just for the same thing as providing, you know, lower level programming in a way that could still be a little more Clojure friendly, you know, quasi-declarative or whatever, and then would hit, you know, fast targets. And that I knew had already been battle tested and would work for a machine learning framework, since it was working with MXNet. But that was also partially kind of just a learning experience for me. I think Chris came at it with way more clear objectives and with a lot more familiarity with the domain in which it was operating. So that's kind of an aside that's probably not worth digging into in detail.
One thing I will say, and I've said this before, TVM is important, not necessarily just because TVM does amazing things, but because it teaches you a different way to think about performance optimization. And any tool that teaches you a different way to think, it's probably worth it, in my opinion, to get to use the tool enough to warp your mind to its way of thinking. Because similar to how functional programming changes the way you think, the TVM system will do the same.
Yeah, Ben, I guess one thing of the many things that you told was really interesting to me, and I hope you could tell about it more, and that was the exact part of the process where Clojure was useful to our people in what they do, and the way you created communication between these two parts. And that, in a sense, I guess, seems very similar to what we're seeing here at my office, where Clojure is used for production and R for data science, and there is some really cute ways to communicate between the two. So I would like to hear more about what you did.
I'd like to talk more about it. I have to jump off for another meeting right now, unfortunately, with those people. But I will say that enough of the project has been considered a success that we are looking at the next steps for presentation, evangelism, whatever, both for the project itself and in general, the tools and possible open sourcing of those tools, or the planned open sourcing of those tools. So I'll let people know as soon as I know more on that front. I'm currently having that conversation.
Yeah, wonderful.
Thanks for organizing this. Thanks everyone for participating.
Thanks, Ben.
Jump off now. Bye.
Bye. Anybody else willing to talk about their project or their wishes or anything?
Yeah. So, so I just kind of, again, a comment, I guess. So I think we all probably have seen the blogs and are aware of the kind of next superpower, from my perspective anyway, with Clojure.spec. I've been using that for kind of data profiling, and I'm kind of excited to try to plug that into some of Tomas's REPL-driven picture workflow there. I think that'd be really cool if I had, you know, a directory full of specs for different types of regular expressions for, you know, 100,000 maps in a seq that I could profile and then get into pictures and things like that. And then I started thinking, I wonder if spec could be used for feature engineering at all, or things along those lines, and how messy that would get. But that's pretty much, yeah, maybe that's something I'll play with. That's all.
Yeah.
Chris, have you had any thoughts about Clojure.spec in your project? Is that going to play a role, or not so much?
I have struggled with spec. I am a very much no holds barred, no rules type programmer.
Okay.
And I know that that causes problems, and I'm not saying there's no place for spec, but for me, strongly typing my data structures is rarely something that I want to do. That being said, what you said reminds me of very strong, like a general purpose strong NLP that can pull structure out of pools of text or streams of text. So all the what are called Q10 reports from all the companies in the stock market, and being able to pull that out into some structured way and do something interesting with it. To me, it feels like there's some parallel there between how you see using spec and kind of being able to pull structured data out of streams of text.
Yeah, it's probably something to play with and never have the confidence to actually blog. That's what happens to me. Yeah, that's interesting. I think it certainly the data science folks probably have that approach. I need to be less, I don't know, less stuck in my ways with I guess trying to know everything about everything in regards to the data I'm processing. But it really kind of, I think that idea, I was at Strange Loop last year. I'm not sure if anyone else was there, but the type-driven program synthesis talk was brilliant. And the speaker spoke in regards to Haskell, but they really looked at generative programming based on kind of like a search problem. So I think that's kind of where this came from. I wonder if there's any opportunity there, but I don't know. I'm getting off the topic here. But thanks.
Thanks. So anybody else? Yeah. So oh yeah. Hi.
Hi, I'm Vijay. Of course, I'm not a data scientist or anything. I just work on data engineering side of it, and then trying to put the data science projects into production. That is one of the biggest challenges that I work on. So just wanted to say thank you for this, initiating this one. And if you guys have an idea about setting up the website or that kind of stuff, I'd be happy to help. And the other one, I was a bit late joining the meeting because I was somehow thought this was yesterday.
Oh.
But anyway, so the other one that I was wondering is, you guys have anybody has looked into something called MLflow, mlflow.org, by the guys who are building the Databricks. That's basically to have like a complete platform for from experiment to production kind of idea. It's written in Python, and this is the kind of tool that not a tool, but a kind of a big frameworky sort of thing that helps a lot in putting data science projects into production, for me at least. So that's what I was following on. So maybe this could be an interesting thing to look into if you haven't already seen it. So basically two things. One, if you have a small working group that you were talking about, Daniel, to set up the website and then compile all the Clojure ML related things, I would love to contribute. And the other one is because I know you guys are way into data science than I am. So if you know anything about MLflow, something of that kind of tool will be extremely helpful for people like me who are leading the teams and then trying to put the data science into production for business. That's it. I think I'll share a link in the chat.
Oh, could you tell a little bit more about MLflow, or maybe share your screen if you wish to show how it looks?
Well, I don't have the installation on me.
Is it over the Spark stack? Is it Spark stuff?
Well, technically it can be. Well, they say you can use it for anything you would like. That's the idea. So because I worked with a big bank in the Netherlands to set up a machine learning project for them in machine learning pipeline using Spark. So one of the challenges is, okay, how do we create multiple experiments and how do we pick the right model and then push it into production? and deploy it onto cloud or on-premise or something. So MLflow is basically like the whole package, or at least that's the aim, to coordinate, or not coordinate, but to design the entire flow of your ML projects, from designing the experiments to all the way up to deploying them using SageMaker on AWS or Azure or something like that. So I'll paste a link. Perhaps you guys
What
can
is
take.
SageMaker?
Oh, SageMaker is AWS machine learning environment.
Oh.
So you can put your own Docker containers onto SageMaker with Scicloj. That's how we deployed our machine learning programs, because our data scientists, they use Python and then they build Scicloj based models. And SageMaker gives an ability to put everything into a Docker container. So we can put an API in front of the scoring or prediction API. So, and it can scale automatically as well. So this is probably some different world that I'm coming from, enterprisey. But the thing is that I understand there is a lot of usage of Python because of the Scicloj and proliferation of libraries being available. But at the same time, there is no tool that can, or no agreed way of putting machine learning projects into production as quickly as possible. That is the biggest pain that we are facing right now. So the data scientists build all that stuff in notebooks, and that's super nice. But then I need to convert that, productionize it, all the way from grabbing the data to actually providing an API that gives the prediction out of the scoring. So I've been researching a lot about researching and Googling essentially for this kind of solution. So MLflow seems to check those use cases. So probably something that as a group, you guys can put your hive mind on and see something at the radar in the future.
Vijay.
Yep.
I think that your perspective is very, very, very important to the group and to myself. Exactly what you just expressed is the impetus of what I tried to design around with, Tech.ml. The data pipelining stuff I talked about. I don't know if you were there for that, but that concept of how hard it is to productize these, you do this very exploratory form of programming, which is great, and then you get a model, and how hard is it to actually produce the same results in production? Well, It's pretty hard, because you generate a whole lot of intermediate states and data and who knows what else. And so I think that moving forward, and how much introspection can a third entity who didn't build this giant training pipeline, how much information can they get out of this training pipeline? Like, what tables does it need to join with? Does it need to filter them? Does it need to sort them, or whatever else? What feeds into this whole data pipeline? I think that's really a really important perspective that we're trying to think about a lot. So thanks a lot for your perspective. It's really valuable to me.
Thank you. But that's the biggest pain point that I see in the machine learning things, because mostly the data scientists, they show me some nice graphs and the notebook is fine and everything is cool. And then now I need to put it into production, and then I need reproducibility. And then they suddenly come up with, oh, we have a different model now. And how can I put the same data into that model? And then when can you put this model into production for us? Because it is of course, the technical evaluation with all the recall, etc. The standard machine learning statistics are okay, but at the same time, I need to think like a product owner, where I need to A/B test different models in production. So these are the challenges that are not solved by any of the current tools. So maybe if I know Clojure community has like amazing ideas, and maybe this could be one of the challenges that we can crack. And then I know there are lots of layers. We need to have algorithms, we need to have performance, we need to have all the stuff required. So maybe MLflow can give you some ideas. And I'm sorry I missed the beginning, so I'm going to watch the recording again to follow up on your presentation. But, thanks a lot for this meeting, by the way. I'd like to attend regularly, at least as a listener.
Yeah, wonderful. And I guess at some point it would be great to hear more about your experience. And So maybe I'll try to tell a little bit about the experience here at my workplace, because it is a bit related to what you're talking about. So here at Localize, a startup doing urban geography, there are lots of data sets, and there is some everyday interplay between the data science team and the data engineering and the R&D teams. And usually it is not about deploying ML, but deploying ETL in a sense, deploying all kinds of data processing defined by the researchers or data scientists, but eventually having to run on production. And then recently it was decided that R would be our main language for data science, but Clojure is the main technology for the backend, for the whole production system. And then it is interesting, and in these days it is like reinvented every time. We need to extend it a little bit, but what some brilliant people here have been doing is defining a declarative way to build a data flow, defining a data flow as data, which is in a sense a bit similar to what Chris has been doing in the Techml system. And being declarative means that it can be seen and analyzed and created on both sides, both on R and on Clojure. And what we are doing now is allowing the R people to define a declarative data flow and run it on Clojure, just as it will be run in production. So they're getting access to the exact way of executing things on production without having to learn Clojure as the main language, but they are able to enjoy it and enjoy it like the joy of working with data in Clojure without having it as a main language. And actually what we are discovering is that R and Clojure are so similar, being functional in a sense and being Lisp in a sense. And so what is becoming here is just beautiful. The way of communication, which does allow, at least on the R side, it allows to enjoy Clojure more and more, and hopefully enjoy Clojure in its fullest flexibility. So it is still a process, but hopefully we will be able to share something. And in our case, at least, it is more about standardizing data processing, about processing all kinds of data sources and inventing a way to reason about them in a unified way. Not so much about an ML in our sense. And yeah, so that's our story for now.
Wow, that's also really, I think you've said that in various different ways, but it's interesting how you're watching a convergence of R and Clojure at your company happen. That is really interesting.
So anybody else willing to tell their story or what they are about nowadays? And if not, then if everybody who are here now, maybe we can talk a little bit about where we're going. So there is a little group of people who are communicating almost every day, and we use Zulip. Do everybody here know Zulip? It is like a chat.
Yeah, I'm there.
Yeah, and for us, at least for several of artists, it has become quite comfortable, I guess, as a way to create work groups, to create small teams who can communicate and keep being focused on a discussion. And I guess what we can try is to, as much as we can, try to communicate there and try to build like a way of creating knowledge which stays, and that can be organized in a sense that it helps to keep an ongoing discussion. And so for now, there are the groups that I mentioned. There is a group talking about tutorials, and a group talking about building a website, and another group which is broader group open for open discussions of data science. And there is also a group which discusses how to build a community. And you are invited to join these groups and see if you wish to influence them. So Vijay, let us talk about it later if you wish, and how we wish to be involved in that. And I guess maybe you can ask ourselves, what is missing in this sense? What is missing for the community to be productive, if anything is missing at all, right? So part of what we found important is actually to be able to meet, to have this kind of video meeting, and maybe face-to-face meeting one day. And what else? What else could be helpful for us to be more creative and more maybe coordinated?
I think if there is a shared, I think Zulip is a nice idea. That's how I knew about this. I keep reading the discussion that you guys are having on Zulip, and that's how I knew about this meeting. So probably if there is a public log or something like that, where you can say, okay, this is what we need to, maybe a GitHub project with the issues or whatnot, that would probably help. And of course, I mean, having the, you know, like the Rust guys, there is, are we web yet? Are we ML yet? You know, something like that, you know, that they show all the components are there or not. Kind of a, we can also say, are we you know, ML yet on Clojure, for example. And then if we can, for me, the most interesting part is if I want to talk to somebody from Python, then I can say, hey, for Scicloj we have this, you know, for Keras we have this, you know, deep learning for J, for example. So that kind of central place where we can point people to for graphing this kind of libraries, you know, for Notebook, Gorilla REPL, or whatever different things that people have built over the period. So I think that would be very helpful, because then it would guide the people in the right direction, in my opinion. So we can collect the ideas, and as I said, I would be happy to work on the web side, because that's what I'm most familiar with. I'm not a data scientist, so I can't help you in that sense. And also on the engineering side, I can explain what I'm working on and the problems, and hopefully push Clojure in different industries that I'm working with.
Yeah, and I guess what you're saying, being able to tell other communities or people used to other platforms to tell what it is about, it is not easy at the moment, the way I experienced it. And our local experience here, we try to teach Clojure to people who are not, to data scientists who are not Clojurians. And all I can tell was that we were trying hard, and what we did was not good enough. And we couldn't create like an effective continuous learning experience where people can just blend into it and feel that it is the right way for them. And I think we should say that at the moment, Clojure is not so beginner friendly for data scientists. And it is related to what Chris was talking about in the talk about popularity. And for data science, popular is important. It probably more than for usual engineers who are like more ready to face the technical problems, because data scientists have to focus on the problem at hand. The technical story is only like a byproduct of working. And I guess in this sense, hearing that Clojure has a bias towards high salaries and more experienced people is not good news, because what it means is that it is not so friendly to the more newcomers and the people who are less experienced. And what we feel here locally at our community in Tel Aviv is that we need to wait. We need to wait for some of the new advances, like what Tomasz and Chris were talking about. We need for things to cool down a little bit before we can try to teach newcomers, and before we can try to sell it to other communities. That's the way we see it here, at least, I guess. Maybe there are other experiences which are more optimistic, but there is a lot to build, the way I feel. Any other comments on that? So maybe it is a good time to conclude, and I guess we will meet again maybe in 3 or 4 weeks. We need to see when the next speaker can set it. And what we will try to do is meet on different parts of the week so that different people of the community can attend. And I know for some of you it is late night, especially Chris Deng. Thank you so much for being able to stay. It is like the middle of the night for you. And anybody wants to say something before we conclude? No? So thanks again, everybody, and Chris Nuernberger. It was like beautiful, and I was so happy to see it. And all the best wishes, and let us meet again soon.
Awesome. Thanks, everybody.
Thanks.
Thank you. And Daniel, you're going to post the recording online on Twitter or something like that, right?
Yeah.
Okay, cool. Yeah.
Cool.
Yeah. Thank you.
So take care. See you soon.
Thank you.
Bye.